draw the diagram, okay, actually it's not useful. Yeah, it's possible. Understand? Okay, it's possible. Okay. Now, same question. Okay, the risk of re-engineering from the perspective of forward engineering. Okay, so all is the answer. Capture object do not integrate to the new system. Okay. Difficulties in migrating the existing data to or for the new system. Degree of preparation for transformation and reverse engineering are not sufficient. Means that the work you do in the reverse engineering is not sufficient. So therefore, you are not able to complete certain part of the new system during the forward engineering. That is a question mark there already. Okay, you ask, what is happening to this part? Still not clear. Understand? Okay. Difficulties in migrating and integrating to or for the new system. Yeah, difficulties. Okay, some part maybe you need to follow back the existing system. However, due to certain reason, let's say for example, maybe the technology compatibility. Okay, maybe the constraint. Okay, maybe the business operation conflict. Okay, so you cannot migrate. Difficult to migrate. Understand? Okay. Which of the following describe the possible risk of re-engineering from the perspective of personnel? This is the answer lah. The knowledge and skill on the existing system is not sufficient. Yes, you do not have the skill. You do not know the language very well. Worse, okay. Do not have thorough understanding on the existing system. Legacy system difficult to understand. Yes. Incorrect assessment on the existing system functionalities. Maybe you have a wrong interpretation on the existing function. You get me? So this one, same question but from the perspective of tools. Okay, tools for reverse engineer is difficult to pursue. Okay, or to purchase that, or to procure. Tools not able to fully derive the high level of code. Yes. Okay, maybe the codes they have applied some method inside so that they won't allow you to really revise back or reverse back the code. Okay, tools are expensive, definitely. Tools require special skill to use. Yes. Okay, so these are the answer. Why so many? Same question but from the perspective of strategy. Okay. Strategy may not be realized completely and correctly. Difficult to decide which strategy to apply. Strategy may not be fully suitable to re-engineer the system. Apply wrong strategy. Okay. Now, principle of abstraction. Which one? This one I guess I have repeated a few times already. Principle of abstraction. What is principle of abstraction? King Yek. Yes, Lim King Yek. Yes. What is the principle of abstraction? Oh, I cannot. Can. If I click then you know the answer already. Never mind lah, I click lah. Okay. So, the level of abstraction of the system representation is gradually increased. Means less info becoming more less info. Understand? Not more info more less info. Understand? Okay. So, and then principle of refinement is the other way around. Okay. The abstract level of the system representation will gradually become less abstract. Understand? Less abstract by adding more info inside. Understand? Then principle of alteration this is the principle where we amend big changes to the system representation, but does not affect the abstraction level of the system. Let's say now you are in the detailed design level of a certain component. You make changes on this design, okay? But it's still considered as a detailed design It cannot become the architecture level Okay, understand? So this is what it means by the principle of alteration. Understand? Okay, this two is the extra knowledge. Won't come out in the assignment, don't worry. Okay, so just for you to understand, program translation and program rephrasing. What is program translation? Translate the program. What is program rephrasing? Rephrase the program. Okay, so program translation actually we change the source code, okay, into another languages. Let's say from Java to Python or Java to Kotlin. Understand? Program rephrasing some sort like you transform the program, okay, but into the same languages. Understand? You change the coding but in the same languages. Means existing system is code A Java, then you transform the system but it's still Java. Understand? So this is the program rephrasing. Okay? Okay, now we continue with our chapter 6. How come today so many students not here? My question is wrong already. I should ask, how come today so many students physically is not here? Okay, so yes, what happened? Is there any event? Oh, career fair. Go for interview. Am I right? Yeah, okay. Maybe, okay. So, let me clear the history first. Okay, now we continue with our chapter 6. Chapter 6. Okay, last week we have discussed, come to here already, okay, the general model of this re-engineering. As you can see that this general model of re-engineering, okay, showing that, okay, the re-engineering process, okay, comprised of reverse engineering, which apply the abstraction principle, okay, then with the high level of representation, then you may alter, okay, alteration made. Those changes we made can be rethink, re-specified, redesigned, and recode. This is the changes, understand? Okay, and then from there, after the changes made, then we proceed to develop the new system. So when we proceed to develop system, this is called the forward engineering. Okay, from high level back to the down to the lower level. Therefore, principle of refinement is applied. Okay, and then in here, this is the principle of alteration. Okay, now, definitely there are many models to describe the re-engineering. This is another model which is called the horseshoe model. Why they call the horseshoe? This one is the horseshoe model. Is because you can see that this is like it's the shape of horseshoe. Understand? It's a shape of horseshoe. You can see that. Okay. So the horseshoe model actually is almost the same one. He described that, okay, the re-engineering model, okay, you can see for the re-engineering of the legacy system, start with the very detailed level, close the lower level, okay, start from the source code, okay. When you understand, you filter, you abstract, okay, to derive the abstract representation of the system. Now, what I said, the abstract representation of the system, actually, it depends on different level. If you are the code level, so what is the abstract representation? Maybe it's the pseudocode, or maybe it's the flowchart. Understand? I mean, in code level. If you go to the design level, maybe it's certain level of component design, okay, or maybe it's the architectural design, and so on. Okay, different level, you may have different representation of the system that come out. Okay, then now for this horseshoe model, you can see that this is a very simple. Then in the slide here, there is another horseshoe model, but it's the same concept, but that one is more detailed on that. Okay, so now in the horseshoe model, start with the legacy system, the basic concept. Okay, we extract, we study the existing system from the lowest level, derive back the abstract representation. come into this higher level architecture. And then definitely this is we need to analyze the high level architecture for the existing system, okay, the old system. Then definitely we need to modify it. Why? Because we need to change it so that, okay, he will switch to the new requirement. Okay, improve modification is here, then improve the structured model, and from here you derive a new system. Definitely there is a series or a stages of development activity is happening here. Understand? Okay, so this is what it is described about the horseshoe model. Describe the re-engineering by the horseshoe model. You can see that horseshoe model. Okay, so according to horseshoe model, same thing. Re-engineering is divided into 3 stages. Okay, so first is the reverse engineering, second is the reorganization or maybe the restructuring that is applying the modification, and then finally, okay, is to develop the new software for further restructuring, further development to derive the new software. So this is the what is described in the horseshoe model regarding re-engineering. Okay, and this is a more detailed horseshoe model showing there. You can see that. Okay, architecture recovery. Architecture is very high level one. Am I right? Okay. Hopefully you still can recall. Okay, architecture is very high level. You can see from the source code back to the architecture, and then do some transformation, restructuring. Okay, amendment. Okay, go to become your architecture, become to the desired architecture which is suitable for your new system development one. And then from there, same thing lah. This is the development process lah, software engineering process. Okay, from high level architecture, proceed detailed design down to the coding level. Understand? You can see the arrow key is follow like this. Okay, it's a horseshoe direction. You can see that. Okay, but now there is an argument there. Argument from others author. Last time I managed to find a source in the website. They argue in this horseshoe model. Is it horseshoe model that we necessary to follow this cycle like this? Can we, let's say, from the the code structure, okay, we derive the code structure representation, then we go to modify it and translate to the code structure for the new system? This website, they argue that it's possible. We no need to code model, then wait for the design, and then come to architecture again and down again. They directly from this here go to here for the horseshoe model. But however, okay, the link of the website okay, is not accessible anymore. Okay, so this is what I find out on until previous semester. The link is the website is still accessible, but until now, okay, I try to access again. The website is not accessible. Okay, just for your information now. Okay, some authors, some websites that argue that, okay, horseshoe model necessary like this one. It can be peer one. Peer means that same level code. You derive back the code representation, you modify, okay, to suit the new code structure of the new system. Understand? Similar to the functional level representation. Yes, this is what they argue lah. Understand? Okay, just for your information. So this is what we describe the 3 main process, okay, of re-engineering in the horseshoe model. Okay, now you can see that from the source text representation, code structure representation, functional level, functional design, okay, and then your architectural representation and the conceptual model of your system, existing one. Then you modify it, then okay, so that you switch to the model of this new system, and then from there you proceed with your development of the new software, which is the forward engineering. Okay, so this is the horseshoe model. Understand class? Can understand okay. So now this is the formula. Okay, this formula is one of the answer in your tutorial 6. Okay, so pass your question. Re-engineering equals to reverse engineering plus the delta. Okay, the triangle plus the forward engineering. Okay, by looking at this one, it's more easier for you to understand the concept of re-engineering. Now, just now we mentioned about the changes on the system characteristic. Okay, recode, redesign, respecify, rethink. You can see it's showing here. Recode, redesign, respecify, rethink. Okay, so the explanation is here. Recode means that we recode the, we change the coding. Okay, we change the coding. Redesign, we restructure the software design structure. Okay, we modify the data model. Okay, maybe we replace the algorithm. Algorithm is considered design. It's not the coding. Algorithm is not the code. It's the pseudocode or the flow chart. Understand? Okay. Respecify the requirement. Change the requirement, which is new one. Okay. Those old requirement don't need already, then you can throw away. Okay. So change. Okay. So that he fulfill the expectation of the new requirement. Change the scope possible. Okay. Rethink. Rethink means that you change the concept of the existing system. Is it the purpose of creating the new system will be the same with the old system? You have to rethink back. Why we need this new system? Understand? Okay. So now we come to re-engineering strategy. Be careful, class. This is the changes. This is the strategy. Different thing. Understand? Because it's also start with the word understand? Just now is recode, redesign, rethink and respecify. Here we come to another topic, which is the software re-engineering strategy. So rewrite strategy. Okay, this rewrite strategy is applying the principle of alteration. Okay, so means that we rewrite this system. Okay, using another languages. Definitely there are some changes but when we talk about principle of alteration means that it does not change the abstract level. Let's say we change the code. Okay, it's a detail level then we should change the code understand? Okay, we did not affect others abstract level one. Okay, we change the code, rewrite, it cannot become the pseudo code or the flow chart already. It's still the code. Understand? Okay, so this is the rewrite strategy. Rewrite the system using another language. Understand? Okay. Now, an operational system is turned into a new system, okay, which is written in another language, but maintain the previous system abstraction level. Understand? Okay. Reward strategy. This one apply the three principles: abstraction, refinement, and the alteration. So means that this one is like the full process of re-engineering. You start with reverse engineering, generate the representation, abstract system representation, and then do necessary modification, and then proceed with the forward engineering. So this is reverse strategy. Okay. The next strategy is replace strategy. Only apply two principles: abstraction and refinement. Okay, abstraction and refinement. So this is the replace strategy. So what is the replace strategy? The system is reconstruct, okay, from the high level of abstraction and then apply the refinement. Okay, with no doesn't apply the alteration. Okay, so this is replace. Then this is your homework. Re-engineering process variation. Okay, please read the. You need to access to this these books the reference book okay. Is it this reference book? No. This journal, I think called journal. Okay, this article. Okay, this article. Look at what is meant by the re-engineering process variation. You can look in the article there is a table on here. Okay, he's saying that okay, this strategy okay, when apply in different level okay, and then what is the depending on the type of changes is it recommended or not recommended? Okay, so go back, read through, find this article. Okay, it's in your notes already. Find this article, read. Okay, check whether okay, read through this one. Let's say for example, for rewrite strategy under the code level, implementation level. Okay, so if I want to apply rewrite strategy for read code, yes. If I don't want to apply the rewrite strategy for the redesign, actually it's not good. Why? Because you have already come to the implementation level. In this case, you may affect the design level. The design has already been confirmed. Understand? So this is what it means by this table. Okay, go and get this article and have a read on this one. Okay, it's a homework. Okay, now we come to the next topic. Approaches of re-engineering. Okay, so there are a few approaches like Big Bang. I don't know why Big Bang is so famous. Okay, we study SQAT also got Big Bang, right? Am I right? No Big Bang, man? Are you sure? You study SQAT, survey testing. No Big Bang, man? No Big Bang. Maybe the statement changed already. Doesn't matter. Okay. So re-engineering approaches. Okay. So we discussed the re-engineering approaches from two aspects. One is the extent of the re-engineering performed, and then the rate of substitution. Okay, of the existing system with the new one. Okay. So now the first approach, Big Bang. Okay, Big Bang approaches actually is developed, suggested by the Korean celebrities band called Big Bang. Is it called Big Bang? So is that right? Okay. No, not like that one. Okay, so Big Bang approach. Okay, actually is those approach when we re-engineer the system at once. Okay, we re-engineer the entire system at once. Understand? So this is called the Big Bang. Okay, so why Big Bang is used? Because the system, the old system cannot be decomposed. The old system difficult and cannot be decomposed. You cannot perform part by part. So therefore, okay, you have to use Big Bang. You have no choice. You have to re-engineer the entire system at once. Okay, so this is called Big Bang. So what is the risk? What is the disadvantages of Big Bang? Okay, benefit means that you maybe if everything runs smooth, then you can complete the system very fast. Otherwise, okay, somehow it's very difficult to identify the risk or the bugs. Okay, at the earlier stage. Why? Because you re-engineer the entire system at once. So if a bugs happen, okay, if any error happen, then you have to spend a lot of time to find this bug actually is caused by which part of the system. Understand? You are not able to detect the error or the bugs in the earlier stage by using the Big Bang. Understand? Okay. Now come to the incremental approach. Incremental approach, this one we gradually re-engineer. Understand? Okay, maybe we divide. Okay, we start with this particular portion first. Then we try to add. Okay, re-engineer, and then after that we proceed with another part of the system. Increment. Understand? Okay. After one increment re-engineer, then we proceed with another increment. Okay. So the best thing is okay, you can easily identify the problem, okay, the mistake in the earlier stage because you are incrementally re-engineer the system. Okay, and then you also able to easy to add the new component because you are one increment, then you add the new component is easier rather than you add the new component into the entire system at once. Understand? So it's easier. Then disadvantage, you have to manage the different version that is produced, okay, throughout the incremental approach, throughout the stages of incremental approach. Because increment, let's say now I do one part, then after that I merge with another part, another version already. Then I merge with another incremental, okay, another version. You have to deal with all this versioning. Understand? Okay? So next approach is the partial approach. This one is it's like this. In the existing system, I identify which part I want to re-engineer. Okay? Then after I have identified the part that I want to re-engineer, then I may use Big Bang or incremental to re-engineer this part. Understand? I may use Big Bang or re-engineer or incremental to re-engineer this part. Okay? So it means that in this partial approach, there are two components. One is those components not to be re-engineered, the part that not to be re-engineered, and those part that required to re-engineer. Understand? Okay? So after you engineer, then you combine back the re-engineer part to those part that no need to re-engineer. Okay, so this is called the partial approach. Partial approach, okay, it's just identify the part that you are going to re-engineer. Then during the re-engineering, you may apply Big Bang or incremental approach to perform the re-engineering. Then after that, you connect back the new part, okay, back to those parts that no need to re-engineer one. So this is partial approach. If I'm smart, okay, I will put a remark here, okay. So then re-engineering approach, okay, the next one, iterative approach. What is iterative approach? Is we carry out, okay, re-engineering on a certain procedure. Actually, the procedure here is referring to those methods or functions. Understand? Okay, on the source code, okay. So, actually, each iteration is very short one, very short short, very short one. Okay, you can finish within a short time, okay. Then after that, okay, you repeat the iteration, okay, with other component, maybe in different stages. Understand? Okay, so this is the iterative approach. I have added some extra info there. Okay, in this iterative approach, this one is how to say, it's more complex than the partial approach, because partial approach there only exists two type of component or parts only. Those re-engineer, those no need to be re-engineered. For this iterative approach, okay, they have allowed the coexistence of the old component that no need to be re-engineered, and then the component currently being re-engineered, the component re-engineered, and the new component added to the system. When you're using this iterative approach, it allows the coexistence of these four different components. That's why you can see I use different color one. Okay, so all components that are no need to re-engineer, not engineer, not so need. Okay, component currently being re-engineered, component already re-engineered, and new component added to the system. Why? Because they're trying to guarantee the operation of the existing system. Understand? When you perform the re-engineering. Therefore, very obvious that, okay, it also preserves the system familiarity. Why? Because all the components coexist together. It still preserve the familiarity of the system. Okay? But however, from here we can see that what is the drawback? You need to keep track on all the component status during the re-engineering. Okay? And also you need to maintain this component during the re-engineering. So this is the drawback of iterative approach for re-engineering. Okay, not for maintenance. Understand? For re-engineering. Okay. Any question? Class. Okay, so now evolutionary approach. This one is almost similar to the incremental approach. Just that, okay, this evolutionary approach, how to say, they are going to group, okay, those related similar functions, okay, into one group. Understand? Okay, they analyze the existing system. They try to group those related or similar functions, okay, into one group, okay, then decide which part is going to re-engineer, which part is not going to re-engineer. Understand? So after this grouping, okay, so and then following this approach, the outcome result, the re-engineer part, okay, the outcome from this evolutionary approach, okay. So this part is very high cohesive one. Why? Because they group, before they re-engineer, they group all those related functions together one. Understand? Okay, group together become one unit when they re-engineer. So therefore, those outcome for re-engineered, the outcome from this approach is very high cohesive one. High cohesion. Understand? Okay, high cohesion. Okay, benefit. It creates a more unified design because they group according to the functions. Okay, reduce the scope of the individual component. Okay, the drawback, okay, you have to spend time to identify those related functions so that you can group them together. Understand? Okay, you get me? Okay, so this is the drawback. And you still have any other evolution? No more already. Any question, class, for this? How many type? 1, 2, 3, 4 type, 4, 5. Class, again, bear in mind, Big Bang approach is not developed by the Korean Big Bang. Understand? Okay. Okay. So I don't know you for your generation you know Big Bang or not lah. Okay. For my generation I know Big Bang lah. Okay. So, but even though Big Bang they also call me uncle already. Okay. So now, any question for these 4 approaches? Can boleh Yes. You Keng Yik is here or not? Okay Keng Yik. Okay Then how about Izen? Yeah, Izen. Where's Izen? Izen group 5. Not here lah. Am I right? Okay, Izen is not here. Group 5. Group 5, any student is here. God, Nigel is here. Castrat is here. That's it. Okay, so this is the re-engineering approach. Okay, now this one just now we came across on the general model of RE. RE means re-engineering. Okay, so we also came across on the horse model of RE. Okay, now we come to another model. This is a source code re-engineering reference model. In short, they call it as a score/RM. Understand? Source code re-engineering reference model. In this model, okay, so there are 4 elements. This model is described on the stages, okay, that how are we going to re-engineer the system from the source code, okay, or re-engineer the source code now, okay. So this is what is described in this model here, okay. Okay, are you ready? This one really very long story one. As you can see, okay, the diagram here depicted by this diagram, okay, there are 4 elements in the model. One is the functions, one is the database. This is the function. that apply, means the stages lah, the activity that apply during the re-engineering of the source code. And then the metrication. When we talk about metrication, definitely is used for measurement. Understand? Okay. And then the next element is the database repository to store those necessary items. And then the documentation, documentation very obvious is the artifact lah. Okay. So this is the basic 4 elements that are involved in the SCORERM. Okay. So this approach is for what? To understand the need of the software, means the requirement of the software. To understand how to rationalize the system to be re-engineered by avoiding data redundancy. Okay, and changing the control flow. Understand how to rebuild the software in accordance with the best practices. So this is another model that represents RE. Okay, there are more than that okay, and V model V model okay, double V model but that one is not in the syllabus okay. So now we come to this SCORERM model. Now look at this model here. This is the existing original source code at the top here. When you go down to all this function here, means that those activity apply okay. You can see this function 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 functions or 8 stages of function here. Then you come to the new source code, the transform source code. You see that? Okay. So from here we can see that there is a re-engineering happened already. Reverse engineering, some functions here is the reverse engineering and some are the forward engineering. But in this model, there is a very special functions. It consists of all the activities of reverse engineering and also forward engineering. So which function is this one? Causation. Okay, take a mark here, causation. The causation functions consists of those activity, reverse engineering and also forward engineering. Okay, that's why I say this one is very special function stage. Okay, causation. Now this is a general description okay. Now we go into the more detailed one. Original source code okay. Then the first level is the encapsulation. What is mean by this one? Management of configuration. In another word, configuration management okay. So I hope that you still know what is configuration management okay. In this stage, you need to determine okay what is the procedure, process, standard, model okay that are you going to follow okay use in the configuration management. Let's say for establish baseline whatever things okay. Then in here you analyze the source code okay. You analyze the source code okay. Maybe you need to convert okay the source code and test case generation. Perform certain generation of test cases to test your coding. Now I guess I have already uploaded this note to the Google Classroom already. Am I? Have you downloaded this one already? Got is it assist or am I upload into the wrong Google Classroom? This one is the explanation, detailed explanation for all these stages here. Got don't have this one, this word document. Got or not tak ada don't have How come maybe I upload into the wrong Google Classroom already. Okay, never mind. I upload again. I upload now
绘文，然后突然间发的帖，是我在小红书发帖，然后我跟绘文是有互加，然后他发我的贴给我看，我想起你不是在发病咩？我发现我买都没亏，就。
Okay, so you can see that this is the detailed description of the stages showing in here. Okay, as you can see that, okay, during the encapsulation functions, okay, so what are the activities performed here? Management of configuration means you need to set up your configuration setting, okay, what model, what procedure, okay, how is the identifier looks like, establish the baseline. Understand? So you can look at here now. The first stage is reverse engineering, is the encapsulation. Okay, management of configuration. Okay, the modification. This one you have to read through yourself, okay. Modification of the program that is being maintained are recorded using well documented and defined technique. Is the configuration management. Understand? You can see that well documentation and defined technique. This is referring to configuration management. Understand? Okay, so analysis, come to analysis here. Okay, another activity, okay, is what is analysis here? Okay, so analyze, access to the existing software, the coding, okay, assisting to the existing coding, okay, and then know the identify the cost model. Identify cost model means that resources and money, understand, in order to perform this re-engineering task. Understand? Okay. So passing here, okay, another activity is passing. Passing here referring to the convert the source code into a intermediate language. I guess you know what is intermediate language, right? What is intermediate language, class? What is this one? If you have learned ASP.NET, you sure know what is IL1, intermediate language 1. Am I right? In Visual Studio, actually the working is like that one. Okay, when you have using C# Visual Basic, understand? You type the code, am I right? So before you run the code, the code is in the exe file, am I right? Okay, so before you run the code, the compiler is going to convert your source code into a certain form of language. Okay, this is called the intermediate language. Since it's used in the Microsoft, okay, if Microsoft Visual Studio, the Microsoft call as a Microsoft Intermediate Language, MSIL. But for other languages in general, we call as an intermediate language. So it means that those language that, okay, is in between the source code and your machine code. Understand? Okay, so in this part, passing means that in the source code, you identify which part is going to re-engineer, and then you identify the cost, model, whatever thing, okay, and then now you start to convert your source code back to its a bit high level. Okay, so convert source code into the intermediate language. Okay, so depending on the relationship of the language to the new code and the old code, it can have different dialect. Okay, the RL represent the source code is used by the re-engineering algorithm. So this is passing. I have a question here. I have a question here. The IL here, the IL refer to here, is it really refer to the intermediate language between the source code and the executable code? This one we need to find out. Because between the source code and the executable code, okay, that one is also called intermediate language. And then between the source code, we derive the source code and the design, okay, they may have some sort of languages that considered as an intermediate language also. Understand? So in this case, okay, you let me find out first. Okay, you let me find out. Okay, we put a remark here. Okay, you let me find out first. Okay, and for the generation of test case, this one is also under the encapsulation. Okay, so you are going to perform some sort of acceptance test. Okay, acceptance test. Okay, to make sure that okay you have achieved a baseline of the source code in this moment. Understand? Okay, so stable version or whatever lah. Okay, understand? So now after the encapsulation, you proceed to the transformation. Transformation, there are two activities: rationalize of the control flow, isolation of external interface. So what is mean by rationalize? Structuralize your control flow means that in your software, the existing one, you try to make it more structured. Okay, and then isolation, to remove all those external interface that is connected to this existing system. Okay, because your target is the existing system, those external interface you need to filter out. Okay, so that okay, what you do, okay, you reduce the complexity, okay, to ease your work. So now, the next stage, normalization, is one of them is the data compression, is to reduce the duplicate data, remove those duplicate data, okay, make some changes in the database, okay, to sweep so that it become more organized and tidy. And then the representation of data, okay, come back to here lah, better. Okay, so normalization, right? Data compression, representation of the data, show that okay the life history of the data is generated. Okay, so it will show that okay this life history of data will help us to understand okay how the control mechanism will work, how the control of the system okay is working. You get me? Okay, and how they're being altered. So the next function is this one. Interpretation. Under interpretation, there are two activities: functionalization and programming reading. So functionalization means that remove all those global variable, introduce recursive function and polymorphic functions. Understand? Okay. And programming reading, maybe you can need to add some comment, okay, to be more clear on what is this coding is used for. Okay. Now again, come to the next slide. Not regeneration, abstraction. Okay, abstraction, we need to identify the object hierarchy. Okay, means the structure of the program lah. Okay, the object hierarchy. Okay, maybe you can create a class diagram. Okay, if not, that is a no object oriented. Maybe you can create a structure diagram for that. Okay, then separate the operator from the data, and then interpretation of the object. Identify the object, okay, refine the object, and so on. Then come to the causation. Specify action that received by the user. Okay, means that what kind of outcome, okay, that should be received by is expected by the user. Okay, come to here, causation. Action must be specified. Action means functions, features lah. Okay, then constraints are specified. Okay, so then move forward to here, regeneration. Create, because now until here, until the level of abstraction here, you already created the abstract representation of the system, existing system one. Then from here, causation, you need to identify okay what are the others functions okay need to be performed, okay, what is the constraint of the new system and so on. Then from here, regenerate, you are going to start to create the new coding, new system, okay? Create the new design, create the new code, and so on. Okay, then you generate the test cases for the new system, certification, make sure the software is safe to use, and then perform some testing so that it really conform to the requirement or expectation. So these are the certification stage. So all the detail is stating here, understand? Okay, so this is the 7 or 8, 1, 2, 3, 4, 8 functions, okay, stages in stages, okay, in the SCORE RM model. Can remember all? Don't go and remember this one, okay? Don't go and remember this one. Then you need to understand, not remember, okay? So now, come to here. Code reverse engineering. Code reverse engineering. Okay? What is meant by code reverse engineering? It's a process of defining the component of operational software, define the interaction between the component, and represent the system at a high level degree of abstraction. Okay, so this is called the code reverse engineering. Actually, it's same meaning lah, but just that this one is applied in the code only to generate the system representation for the code. Understand? Okay. Now continue. The factors that need to, the factors that necessitating the needs of reverse engineering. Why we need to perform code reverse engineering? Because the programmer has run away. Language become obsolete. Language is very old. Okay. Insufficient document. The business is rely on the software. The company acquire the system as a part of the larger acquisition and lack access to all source code. Okay, they do not have fully access to the source code. The system require adaptation, system may require enhancement. Understand? So therefore, this is the reason that we need to perform code reverse engineering. Okay. These are some techniques, okay, for code reverse engineering: lexical analysis, syntactic analysis, control flow analysis, data flow analysis. What else? Program slicing, visualization, program metrics. Lexical analysis actually is to break the codes into a single unit of bytes. Understand? Okay. Lexical analysis. Break down the code in a sequence of character. Let's say your code is let's say system.out.println, okay, hello world. You break this code, okay, into a sequence of character. Okay. So then you can use the lexical analyzer, okay, to break it and analyze, okay, what is what is this code is actually for. Understand? Okay. During compilation, this one is using, just that we cannot see only. And then for the syntactic analysis is to identify the syntax. Check on the syntax of the coding. This one is using the tools now. We can don't manually go and do it. Okay, syntax analysis, syntactic analysis. Okay, performed by a parser. Okay. And during syntactic analysis, we can use this Becker's norm form. Okay, to show, okay, to describe the grammar of the particular programming languages. So what is meant by this form? Look at this example. This is the example of BNF, Becker's norm form. Okay, you can look at this one. It describes the syntax. Look at that. Block equals to variable ident, okay, curly bracket, comma, is showing the syntax, okay, of the languages, BNF form. Okay, so we need to use the parser to do it. And another reverse engineering technique, control flow analysis. This one is to analyze the flow of your system or the flow of your program. Understand? Intra-procedure analysis means that you analyze the flow of your coding within the same function, within a single function. Inter-procedure analysis, you check the flow and the dependency, okay, between different functions. Understand? So this is the difference only. Okay. The control flow analysis, we analyze the flow of the system. Okay. So if intra means that the flow of the code within the single function. Inter means that the flow of the code between different functions. Understand? Okay. So intra-procedure analysis, you can use CFG. CFG means control flow graph. Understand? Okay, this one you have practiced already. Inter-procedural analysis, maybe you can use the help of the call graph. Call graph means that it shows that which function is calling which functions. Understand? The relationship between the functions. Okay. Data flow analysis. This one you need to check how the data is flowed throughout the program or throughout the functions. Understand? Okay. Then from this data flow, okay, you can know that okay, which code is never perform one. Okay, never execute one. So that one is a dead code lah. Program slicing, this one. Program slicing is a technique. We extract related statement from the coding. Understand? Either based or not based on a certain criteria. Understand? Based on a certain criteria, we extract related codes from the existing program. Okay? And then this extracted codes is called program slice. Understand? So therefore, it's called as a program slicing. Okay? So there are many techniques in program slicing. One is the backward, one is the forward. In general, backward slicing, okay. Backward slicing means that, let's say for example, for backward slicing, let's say for example, I have 50 lines of code. Understand? Okay? Then, by given a criteria 1, okay, let's say the criteria is from line number 15. Okay? Then I will look back on this one, all these line before the 15, okay? Which line of the here will affect the value of line 15, the value of variable in line 15. So I expect how. So this is called backward. Forward is different. Forward is, let's say, okay, line 15 given a criteria, okay, which of the below statement is affected by the criteria at line 15. Understand? Forward, backward. So these are the difference only. Okay? We extract the slice, the statement come out. That's it. Continue next chapter. Chapter 7. What is the time now? Okay, so any question, class? Now, I know that the most difficult part for this chapter is the score IN model. Okay, the many stages one, okay, score IN model. But don't go and memorize the function in the score IN model. Understand? You just need to understand what is the score IN model you do already. How to memorize so many? Right? Okay. Don't go and memorize. Just to understand. Okay. Just to understand. Don't go and memorize. Okay. Yes. Any question, class? Any question? As I think I have discussed with group 2. Okay. So we want to do a survey, okay, on the most effective words applied in lecture. What are the most effective words applied in lecture? First one, class, attendance good, okay. Second, we can dismiss already, okay. The third,